Hello friends, welcome to the video tutorial on Firebird 5 robotic research platform. This platform is based on ATmega 2560 microcontroller which belongs to AVR architecture family. In this tutorial, we will learn the basic I/O interfacing on Firebird 5 robot. Now let us see the agenda for discussion in this tutorial. The presentation will start with the discussion of input-output ports of ATmega 2560, which includes overview of ports and methods of accessing the ports with the help of various examples. Then we will learn how to write our first embedded C program to beep the buzzer interfaced on Firebird 5 robot. What are ports? Ports can be defined as junctions where peripheral devices can be connected. Peripheral devices can be classified as input devices or output devices. Input devices are the devices which give signal to the microcontroller, for example, switch, sensor, etc. Our peripheral devices are output devices. Output devices are the devices to which the microcontroller will send the signal, for example, buzzer, LCD, motors, LED, etc. Now let us see the ports present in ATmega 2560. ATmega 2560 is a 100-pin microcontroller, out of which 86 can be used as input or output pins for I/O interfacing. These pins are grouped together and are called as ports. The pins are called as ports because if you want to access any of the peripheral devices, you have to do it by putting the address of it, that is to which the pin a particular input or output device is connected. To address 86 pins is very difficult, so these pins are grouped together and are called as ports. In ATmega 2560, we have 10 8-bit ports named as port X, where X is the name of port and X will vary from A to H, J, K and L. ATmega 2560 has one 6-bit port which is named as port G. All ports pins can be configured individually as input or output pins as per device connected to it. Thus, in last slide we studied there are total 11 ports. In this slide we will see the pinout of ATmega 2560. Gold color in the right corner indicates the port A. Next, on the right side there are two ports named port J and port C in green and red color respectively. Bottom of pinout highlights two more 8-bit ports, port D and port L in brown and lavender color. Port B, port H and port E are highlighted using grey, orange and light green that are present at left side. Top indicates port K and port F in indigo and yellow color respectively. At the end we have a 6-bit port G in purple color. Now let us see how to access the ports. In AVR architecture, each port has 3 resistors associated with it. We have to use these 3 resistors for configuring a port. The first resistor is DDR-X register, where X can be replaced by the name of port, that is A to H, J, K and L. The second register is port X register. Similarly, the third register is pin X register. We will now write the first program using these 3 resistors. The first program in this tutorial is to interface the buzzer on Firebird 5 robot. Buzzer is connected to port C, pin 3. This is the simple diagram of buzzer connection in which buzzer is connected to port C, pin 3. As shown in figure, to turn on the buzzer, we send logic high on pin 3 of port C. And to turn off the buzzer, we must send the logic low on pin 3 port C. Now let us proceed with writing the program. We shall first configure port C, pin 3 as output. So the value of DDR-C should be 0x08. Now to turn on the buzzer, set port C pin 3 as high. So the value of port C will become 0x08. And to turn off the buzzer, set port C pin 3 as low. So the value of port C will be 0x00. Here we have written the code in Atmel Studio 6 for buzzer interfacing. For generating the hex file, go to Build option in toolbar, then select Build Solution, or we can press F7 also. In the output window, we will get Build Succeeded message if the code is correct. We can find the hex file in the debug folder located inside the project folder. Here, it is with name buzzer.hex. Open command prompt by pressing Windows plus R keys and type cmd. Next, navigate to the directory where avr.doot folder is. Here, it is on desktop, hence we type cd desktop/avr.doot and press enter. To burn any hex file onto the robot, we type stkrun space and the directory path of the hex file. Drag and drop the buzzer.hex file in command prompt. The path of the file gets pasted into it. Now turn on the Firebird 5 robot before pressing enter. Now press enter to load or burn the hex file onto the robot. Once the hex file is loaded, we get the message as avr.doot done and thank you. As soon as the hex file is loaded, the robot starts executing the program. So we can hear the beeping of buzzer at interval of 1 second. Following are the references. First, ATmega 2560 datasheet. Second, hardware and software manual of Firebird 5 robot. So here we have successfully understood the basic I/O interfacing on Firebird 5 robot. With this, we have come to an end of this tutorial. Thank you for listening. This is Binu signing off.